Lesson 4, regular polygons. So when we have a regular polygon, what that means is that all the sides and all of the angles are equal. So we have a formula that will help us figure out the angles. It will tell us both the sum of the entire shape and it will tell us the individual angle. So this one says determine the degree of each of these shapes. So we're going to just make a chart here. And we're going to do each one. So we're going to start with pentagon. So a pentagon has 5 sides. So we're going to do 180 times 5 minus 2 divided by 5. We just plug a 5 in for that n value. So what that would get you is on the top you should have 540, which means that all of the angles in a pentagon add up to 540. Just like in a quadrilateral they add up to 360, and in a triangle they add up to 180. And what this tells us is that each individual angle would be 108 degrees. Our next shape is a hexagon. If you're unsure of what these shapes look like, a pentagon looks like that. A hexagon looks kind of like a stop sign. So that's what we're dealing with right now. It has 6 sides. So we would do 180 times 6 subtract 2 divided by 6. When we type in the top, we would get 720. So the sum of a hexagon is 720, making each angle worth 120 degrees. Our next shape is a heptagon. So a heptagon has 7 sides. I'll change the color. So we would do 180 times 7 subtract 2 divided by 7. Our sum of a heptagon is going to be 900 degrees. When we divide by 7, that makes each one of them 128.6. Next is an octagon, which is like a stop sign. So we would do 180 times 8 subtract 2 divided by 8. The sum of an octagon is 1080. Divide that by 8 and each angle is worth 135. Our next shape is a nonagon, which is something with 9 sides. So we'll do 180 at 9 minus 2 divided by 9. The sum of a nonagon is going to be 1,260 divided by 9. Each angle is worth 140 degrees. And we also have to do octagon and decagon. Dodecagon and decagon. So let's do decagon first. So a decagon has 10 sides. So we're going to do 180 times 10 minus 2 divided by 10. When we type in the top, it's 1,440, making each angle worth 144 degrees. And a dodecagon has 12 sides. If we type this into our calculator, we have 180 times 12 subtract 2 divided by 12. The sum of a dodecagon is 1800 and each individual angle is 150. So utilizing this, we can use it when we talk about tessellations. So a tessellation is a pattern that can repeat itself or tile itself over and over again. And we could do this with regular shapes because they will fit. So what you're actually looking for is for things to add up to 360 degrees. So if they add up to 360 degrees, then they can tile, they can continue on. So a lot has been subdivided into 3 shapes: a regular pentagon, an equilateral triangle, and a square. There will be one section left in the lot. Determine the degrees of the last section and will this be regular? So let's add all these up. So using our chart from before, a pentagon has 108 degrees. We know that equilateral triangles are each worth 60 degrees. And we know that a square is worth 90 degrees. So what this would look like is they're sitting beside each other, so we could have the pentagon, the square, and then the triangle. So we want to figure out what's left here, and can we make it regular? So when we add all of this up together, we get, we're going to subtract this all from 360. So what we would get is 258. So if I take 360 and I subtract 258, I'm left with 102 degrees. So we want to see if 102 degrees is a regular shape. So going back to all the questions we just did, we have 108, we have 120, and it just keeps getting bigger. None of those are going to be 102. And the shape smaller than a pentagon, so 5 sides, would be a square, which has 4 sides, which is 90 degrees, which is not 102. So the remaining shape is not going to be a regular shape. It would have to be something that is worth 102 degrees. So it is not regular. So just remember that tessellation means it is regular, it adds up to 360.